All right, 3.2, part 2.
Okay. Reminder, in the coordinate plane, an angle is in the standard position when its vertex is at the origin and one ray of the angle lies on the positive x-axis. The terminal ray is the second ray of an angle in the standard position.
All right, so we're starting at the x-axis and we're moving, and we're going to go to the terminal. All right, just like an airport, you're going to a terminal. All right, positive and negative angles.
Positive and negative angle measures simply indicate the direction of the rotation from the positive x-axis. Positive angles are in the counterclockwise direction. Negative angles are in the clockwise direction.
All right, so positive angles go counterclockwise, negative angles go clockwise. All right. All right, so when we are measuring angles, we are going to take an arc length over our radius. All right, so when we are getting our theta measure, we are getting an arc length over a radius. All right, Caroline, you want to keep going on this part, the radian?
Wait, where? The radian measure of an angle in standard position is the ratio of the length of the arc of a circle centered at the origin created by the angle to the radius of that same circle.
All right, so again, it's going to be our angle measure is our arc length over our radius. Now, how do we find an entire way around my circle, also known as a circumference? How do we figure out the entire circumference of a circle? 2 pi r. All right, and so our circumference is given by 2 pi r. And then we need to find a ratio of that because it's not going around an entire circle all the time. And so it could go a different amount. So the entire circle would be given by 2 pi. All right, and we'll talk about that in example 1.
Consider the angle theta created by the quarter circle of the radius 4 above. Find the measure of thetas in radians.
All right, so here we go. So we're going to find our entire circumference of what this circle could be before. And so how do we find circumference again? 2 pi r. And so we'd have 2 pi times my radius, in this case, is radius of 4. And so our entire circumference would be how much? 8 pi, right? However, this is a quarter of my circle. So what is the arc length of this part? I would divide by what? I would divide by 4. All right, so I'd take 8 pi, and I'd divide it by 4, which is how much? 2 pi. And so this arc length is 2 pi. To get to my angle measure theta, I'd take my arc length and divide it by my radius. I'd take my arc length and divide it by my radius. And so I'd have 2 pi as my arc length over my radius of how much? 4. And so I'd end up with pi over 2. And so my angle measure in radians for a quarter circle is pi over 2 radians. All right, let's go to example 2 now.
Find the measure of the angle formed by a third of the circle with radius 3 centered at the origin in the clockwise direction.
All right, so this says it's going in the clockwise direction of the radius 3. And so I would actually be going backwards on this. All right, and so my circumference is kind of like a negative 2 pi times my radius. And so I'd have negative 2 pi, and then my radius of what? 3. And so my entire circumference is going to be what? Negative 6 pi. All right. And so I know a distance is really like a measure around something, but just kind of go with it because now we're going backwards. And so we have negative 6 pi. Now, I want to take that and divide it by 3 because it says it's a third of my circle. So really, I'm going to have my terminal ray going a third of my circle. And so if I were to split this up, it'd kind of be that part right there. And so now I'm going to have negative 6 pi times 1/3, which is how much? Negative 2 pi. But to find an angle measure in radians, I take my arc length. So this arc length is negative 2 pi now. And so I take that negative 2 pi and I divide it by my radius. And so my radius is how much? 3. And so this angle measure right here is negative 2 pi over 3. Okay? Now, I want to kind of break this down a little bit before we keep going. And so when we start talking about our circle, all right, we're going to talk about a unit circle in just a sec, but I just want to talk about any old circle. Our angle measure, it takes how long to go all the way around a circle? Okay, we're not in degree mode. We're going to talk about radians now. And so an entire way around my circle is how much? 2 pi, all right? Because my radius, my circumference is 2 pi r, right? And then if I divide by r, guess what happens? My radiuses cancel, and so my angle measure would end up being what? 2 pi. And so my entire way around my circle is 2 pi, all right? Now, halfway around my circle would be what then? Would be 1 pi, all right? And so we just call this pi. Now, in between 0 and pi would be how much? Pi over 2. It's half of pi, right? And then in between pi and 2 pi would end up being how much? 3/2 pi, or what I call 3 pi over 2. All right, 1.5 pi. All right, and so those are kind of our axes of our circles. All right, so now let's talk about what a unit circle is. All right, so a unit circle is a circle centered at the origin with radius 1. All right.
For a unit circle, the radian measure is the same as the length of an arc formed by the angle. The concept of the unit circle will become pivotal throughout the rest of this course because of its incredible usefulness when working with
Trigonometric values. All right. I'm going to teach you some Latin right now. Does anybody remember what geometry means? Does anybody know what geometry means? No? No? The metry part means measure. Does anybody know what geo means? No? Earth. Like geography. All right. And so it actually means the measure of Earth. That's what geometry means. And so when we're talking about trigonometric, like trigonometry, guess what that means? The metry part is still measure, and the trig part, guess what that looks like? Triangles. So trigonometry actually means the measure of triangles. All right. And so there's the Latin for it. All right. So let's look at example 3 here. And so we're going to find our given arc length, and we're going to find our corresponding angle to those things. And so we have 1/6 of the circle in the clockwise direction. Again, how much is all the way around my circle? 2 pi. And so now I'm going to multiply that by what? 1/6. And so 1/6 of the way around my circle would be how much? Pi over 3. All right, 1/3 pi. All right. All right, let's go to part B now. It says 2 full revolutions in the clockwise direction. If I'm going clockwise, what is my angle? It's negative. All right. And so one way around going backwards would be how much? Negative 2 pi, right? But how many of them are there now? 2 of them. And so what would be my angle theta in this one? Negative 4 pi. All right, cool. All right, let's look at this next one. So we kind of already talked about this one. So 3/4 the way around my circle in the clockwise direction. And so again, what's an entire circle? 2 pi, right? And then we're going to multiply this one by 3/4. And so 3/4 around my circle is how much? 3 pi over 2. All right, 3 over 2 pi, you could call it, I guess. All right, so 3 pi over 2. All right, let's do 7/8 away around my circle now. All right, and so now, again, the entire way around my circle is how much? 2 pi, and then 7/8 of it, the way that I think about it is like do 2 over 8, which simplifies to like 1/4, and then we got a 7 up top, and so now we get to what? 7 pi over 4, right? All right, so let's look at this unit circle and kind of fill in the blanks. All right, and so I'm going to teach you some ways, okay? And I'm not going to teach you every single trick today. However, I'm going to teach you some ways to remember where angle measures go, okay? Sound good? All right, and so real quick, just to begin, we have pi over 6, pi over 4, pi over 3. All right, they're always going to be over 6, 4, 3, I guess half, but these are kind of your axes. All right, and so I'm actually going to fill in the axes first, okay? We kind of already did this. All the way around my circle is how much? 2 pi. And so I got 0 and 2 pi going on, right? And then halfway around my circle would be what? Pi. Now, the pi over 2 is already filled in. Between 0 and pi would be pi over 2. But in between pi and 2 pi, again, is what? 3 pi over 2. All right? We just kind of talked about that algebraically by saying 3/4 the way around my circle. So we get the 3 pi over 2. All right, so now I'm going to talk about the pi over 6's. All right? And so pi over 6 is located near the what axis? The x-axis, okay? And so I kind of want you to recognize that pi over 6 is located near the x-axis. That's what I want for right now. Now, I want a common denominator with a 6. So instead of thinking of it as pi, I'm going to call it 6 pi over 6 because I want a common denominator of a 6. Does everybody understand that 6 pi over 6 is the same thing as pi? Is everybody good there? Cool. And so I'm going to subtract pi over 6 from 6 pi over 6. And guess what I get? I get 5 pi over 6. So 5 pi over 6 is located right there because I subtracted pi over 6 from 6 pi over 6. Everybody see how that happened? All right. Now I'm going to add pi over 6 to 6 pi over 6. And guess what I'm going to get? I'm going to get 7 pi over 6. And so 7 pi over 6 is located right there. Now, 2 pi with a common denominator of 6 is the same thing as saying what? 12 pi over 6. And so I'm going to think of that 2 pi as being 12 pi over 6. Same thing. And so now I'm going to subtract pi over 6 from 12 pi over 6. And so then what would I get? 11 pi over 6. And those are all the pi over 6's on my unit circle. So here's what I want you to remember. Pi over 6's are located where? Near the x-axis. All right? And they go 1, 5, 7, 11 because we like Slurpees. All right? And so, you guys know Slurpee Day 7-Eleven? Okay, good. All right. And so the way that we're going to remember it is it goes 1, 5, 7, 11. All right. And the way that we came up with 5 and 7 is to subtract and add pi over 6 to that 6 pi over 6. And then we're going to find 11 pi over 6 by just subtracting pi over 6. Sound good? Cool. All right. Now we're going to work with pi over 4's. So pi over 4's are always going to be in the middle. All right. And the reason being is like if you have like pi over 2 and you divide it by 2, guess what you get? You get pi over 4. And so it's going to be in the middle between 0 and pi over 2. That's where pi over 4 is. It's in the middle. All right. And so the way that I'm going to do it is I'm going to kind of add pi over 4. All right. So if pi over 4 plus pi over 4 is pi over 2, right? And then if we add pi over 4 to pi over 2, so this is like 2 pi over 4, right? So I got 1 pi over 4, 2 pi over 4. Then this one would be what? 3 pi over 4. And so this guy is 3 pi over 4. And then if I add another pi over 4 to it, it'd be like 4 pi over 4, also known as pi. And then I'm going to add another pi over 4 to it. And so if I add another pi over 4 to it, now I'm at what? 5 pi over 4. And again, guess where they're still located? In the middle. And so then we're going to add another pi over 4 to it. So I get 6 pi over 4, which can simplify to 3 pi over 2. But we're just right now going to call it 6 pi over 4 because it's easy. And so then I'm going to add another pi over 4 to it. And what do we get? 7 pi over 4. So 7 pi over 4 is located right there. And then again, if I were to add another pi over 4 to it, I'd get 8 pi over 4, also known as 2 pi. All right? So there's a couple things I want you to recognize about pi over 4's. Where are all the pi over 4's located? In the middle. What do you notice about all of them? They are all what? Odd. They're all odd. Okay? And so they go 1, 3, 5, and 7. All right? Pretty cool. All right. The next thing we're going to come to is pi over 3. And guess where pi over 3 is located? Near the what axis? Near the y-axis. All right? That's kind of important. So pi over 3 is located near the y-axis. And so if this is pi over 3, I'm going to add another pi over 3 to it to get to what? 2 pi over 3. And so that one is 2 pi over 3. Now, in my head, I actually think of this part as 3 pi over 3. All right, so pi is like 3 pi over 3. And then if I add another pi over 3 to it, guess what I get down to? I get down to 4 pi over 3. And then my next one would be 5 pi over 3. And then we'd go one more, and we'd get to like, that's not over 6. What in the world? So 5 pi over 3. And then I'd add another one to it. Oh my gosh, it froze. Pi over 3 right here. All right. And then this would be 6 pi over 3. All right. So let's quickly review. Where are all the pi over 6's located? Near the x-axis. And how do they go? 1 pi over 6 and then 5 pi over 6. And we love Slurpees, so we got what? 7 pi over 6 and 11 pi over 6. Pretty good. Where are all the pi over 3, or where are all the pi over 4's located? In the middle. What do you notice about them? They're all odd. So this is 1, 3, 5, and 7. Where are all the pi over 3's located? Near the y-axis. All right, because the y is going to be bigger when we start actually evaluating unit circle. I want you to think of the y-axis being next to it. And so we got pi over 3 and 2 pi over 3. I like to think of this as 3 pi over 3, but I'm not that smart. And so then this is what? 4 pi over 3 and 5 pi over 3. All right, the really smart people can just go 1, 2, 4, 5. All right, I always have to do 3. All right, all right. So now we're going to talk about sine, cosine, and tangent. Does everybody remember my Native American princess? What was her name again? Sohcahtoa. So sine dealt with what? Opposite over hypotenuse. But in our unit circle, guess what my hypotenuse is every time? My hypotenuse is 1 because it's a unit circle. All right? And so that's what it means. So my hypotenuse is 1. So on sine, it's just my y over 1 because it's my opposite over my hypotenuse. So this is what I need you to remember. So sine deals with what? Y. Okay? Sine deals with y. Cosine, remember ka, adjacent over hypotenuse. So my adjacent would be what? X. And my hypotenuse is 1 on my unit circle. All right? And so cosine always deals with x. What about tangent? So tangent is, so toa, right? And so it's opposite over adjacent. See, the opposite is what? Y. And the adjacent is x. So tangent is what? Y over x. All right, let's put it into use, but we're going baby steps right now. All right, I need a good reader. I love that.
The figure shows a circle centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle intersects at a circle at point C. The coordinates of P are 1/2 over square root of 3 over 2. Find the following values.
All right, beautiful. All right, and so the first one we need to do is find the sine of theta. So sine deals with what? I want you to think of y. Sine deals with y. So what is the y? Literally tells you. Sine deals with y, which is square root of 3 over 2. Love it. All right. The next one is cosine. Cosine deals with what? X. So what do we got? 1/2. And then tangent. Tangent deals with what? Y over x. So my y is what? Square root of 3 over 2 over 1/2. And so what happens to the 2's? They cancel. And so now we're left with square root 3. All right. Let's look at example 6 now.
The point R is the result after point P is reflected over the y-axis. Let A be...
Oh, no. Go.
Let alpha be the angle
Thank
in
you.
standard position whose terminal ray intersects the circle above at point R. Find the following values.
All right, so R is going to be reflected over the what axis? The y-axis. So it's going to reflect over the y-axis like that. And so what changed? Did the x or the y change? The x changed because it's reflecting over the y. And so my x is actually at what? Not 1/2, but negative 1/2. And the y is what? square root 3 over 2. All right, and then my terminal angle, all right, or my angle is alpha to go to my terminal ray R. All right, so now we need to find the sine of alpha. So what do you want to think of as sine? The y. And so what is the y? Square root 3 over 2. All right. Now the cosine of alpha. So cosine deals with what? X. So what's the x? Negative 1/2. All right. And then the tangent of alpha. How do I want you to think of tangent? Y over x. And so now we'd end up with square root 3 over 2 over negative 1/2. What happens to my 2's? They cancel. It's better to keep a negative on the bottom. So now we're left with negative square root 3.